This is a 2022 ECE gate problem on filters. The question is, consider an FM broadcast that employs the pre-emphasis filter with frequency response HPE omega equal to 1 plus j omega by omega naught inverse, where omega naught is equal to 10 to the power 4 radians per second. For the network shown in the figure to act as a corresponding de-emphasis filter, the appropriate pair or pairs of RC values is or are, and here are the four options. So option A is R should be 1 kilo ohm and C is 0.1 microfarad. Option B is that R is 2 kilo ohms, C is 1 microfarad. Option C, R is 1 kilo ohm and C should be 2 microfarad. And option D is R will be equal to 2 kilo ohms and C should be equal to 0.4 microfarad. And this is an RC circuit, so basically this acts as a low pass filter. And if we proceed with the solution, we know that this acts as a divider network. We can think of this as a divider network, and since we are interested in the output, so we can frame it as, in the Fourier domain, this can be written as 1 by j omega c. Or if you are comfortable with the Laplace domain, you can write this as 1 by SC and then proceed with solving for the transfer function and then replace S by j omega, indicating steady state operation. So anyways, we have taken it to be 1 by j omega c, which is the capacitive reactance, and we know that this V out by V in j omega will be this impedance divided by the summation of this total impedance, and therefore this is equal to 1 by j omega c by R plus 1 by j omega c, upon which we get the transfer function in the frequency domain to be equal to 1 by 1 plus j omega rc after solving for this. Now in the question it is mentioned that the transfer function is equal to 1 by 1 plus j omega by omega naught, and therefore if we match these two equations, it is easy to see that omega naught is equal to 1 by rc. And note that this omega naught is actually the cutoff frequency of the filter, and rc is called as the time constant of the filter. So rc is equal to 1 by omega naught, and omega naught is mentioned as 10 to the power 4 radians per second, and therefore rc should be equal to 10 to the power minus 4 seconds. Now if we look at the options one by one, because we have two unknowns whereas there is a single solution, so we have to look at the options and we have to pick up the correct choice or choices. So first option was R is 1 kilo ohm and C is equal to 0.1 microfarad, and therefore if we break them down to their basic units, then we find that RC comes out to be 10 to the power minus 4 second, and this exactly matches with the information that is provided in the question. So if we choose R to be 1 kilo ohm and C to be 0.1 microfarad, the cutoff frequency will be 10 to the power 4 radians per second. Second option was R is equal to 2 kilo ohms, C is equal to 1 microfarad, and if we proceed with the multiplication, we find that this is not equal to 10 to the power minus 4. If we look at option C, then again this also does not match with the RC value that is provided in the problem, and with option D also RC turns out to be 10 to the power minus 3 seconds, and this is also not matching with the information that is provided in the problem. So there is only one correct solution to this question, and that is equal to option A, where R should be equal to 1 kilo ohm and C should be equal to 0.1 microfarad. So this was a pretty simple problem and it could be remembered. You do not even have to go through trying to obtain that voltage divider equation, if an RC circuit is given, then simply remember that the cutoff frequency is equal to 1 by RC.